Welcome everyone. This video is the fourth part of chapter 3 Atoms and Molecules, class 9th chemistry. Chapter 3 Atoms and Molecules. So we have seen the postulates of Dalton's atomic theory in the part 3, and the postulates of this theory are: all matter is made up of very tiny particle called as atom was the first postulate. This matter is composed of very tiny particle called as atom was the first postulate. Second postulate was atom are individual particle. So atoms are individual particles which cannot be created nor be destroyed in a chemical reaction. Meaning is that a chemical reaction must be balanced. You cannot create an atom and cannot destroy an atom in a chemical reaction. And the third one postulate was atom of given element are identical in mass and chemical properties. So for a given element, atoms of that element will be identical in mass and chemical properties. And the atoms of different element have different masses and chemical properties was the fourth postulate. So the third one and the fourth one postulate is saying to you the atoms of same element are identical in mass and chemical properties, and the fourth one is atoms of different element have different masses and chemical properties. Fourth one postulate, fifth one is the atom combine in the small whole number ratio to form compounds. So atom will combine to form compound. So they will combine in a small whole number ratio. And this postulate will give you the idea of law of constant proportion. And the sixth postulate was the relative number and the kind of atoms are constant in a given compound. So the relative number and the kinds of atom are constant in a given compound. So whatever compound you will consider, the kind and the number of atom in that element will be always same. So it was the first theory which was based on laws of chemical combination. Now we will move to the drawbacks of this theory, and the drawback of Dalton's atomic theory are: drawback of Dalton's atomic model. The first and the very major drawback of Dalton's atomic model was atoms are individual particles. At the time of Dalton, the discovery of electron, proton, and neutron had not taken place. So people used to use this postulate that atoms are individual particles. But it was proved wrong by the discovery of electron, proton, and neutron. So the first one drawback is that Dalton's theory states that Dalton's theory states that atoms are individual particles. Atoms are individual particles. But it was proved wrong it was proved wrong by the discovery of electron, proton, and neutron. Means by the discovery of electron, proton, and neutron, it is further explained that atom can be further divided into electron, proton, and neutron. And it was proved wrong that atoms are indivisible. Atoms are divisible into electron, proton, and neutron. So it was the first drawback of Dalton's atomic model. So after the discovery of electron, proton, and neutron, and neutron, the first postulate of Dalton's atomic model became wrong, and it is the first and major drawback of Dalton's atomic model. So, if the question is saying to you what is the major drawback of Dalton's atomic model, so the answer is atoms are indivisible particle. It is the major drawback of Dalton's atomic model. Now we will come to the next drawback of Dalton's atomic model, which is the second drawback. Dalton's atomic model could not explain about isotopes and isobars. Meaning is that about the isotopes and isobars, Dalton's atomic model wasn't able to explain this. For an example, if we are considering the isotopes of hydrogen, which is 1H1, 1H2, 1H3, protium, deuterium, and tritium. So here you are finding atoms of same element have the different masses, 1H1, 1H2, and 1H3. It is the atomic number and it is the atomic mass. So the third postulate of Dalton's atomic model was atoms of same element will have the same mass and chemical property. But here you are finding the atoms of same element, which is hydrogen, have the different masses. So when these isotopes came into picture, the third postulate of Dalton's atomic model became wrong. And if you are considering these isobars, argon and calcium, which is 1840 and 2040. So here you are finding this argon and calcium, these two are different elements. An atom of different element have the same mass here, which is 40 and 40. But the fourth postulate of Dalton's atomic model was atoms of different element will have the different masses and chemical properties. But here you are finding different atoms of different element have the same masses. So when this isobars came into picture, the fourth one postulate of Dalton's atomic model became wrong. However, about this isotopes and isobars, you will study in detail when you will go to the chapter number 4 of your class 9 chemistry. But for this time, you can remember that isotopes of hydrogen will be this only, and example of isobar is argon and calcium. Now, if we will come to the fourth drawback of Dalton's atomic model, not fourth, third one, which is Dalton's atomic model could not explain about dissimilarities in the properties of allotrope properties of allotropes of an element. Sorry. So allotropes of carbon can be diamond, graphite, Buckminster fullerene. So you will find the dissimilarities between these allotropes of carbon. And about this, Dalton's atomic model wasn't able to explain. So Dalton's atomic model could not explain about the dissimilarities in the properties of allotropes of an element. Was the third drawback of Dalton's atomic model. So it was all the drawbacks of Dalton's atomic model. You can write down one homework, that what are the allotropes of carbon. Thank you all.